Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 11 to 15 of the August 2016 Algebra 1 Common Core New York Regents exam. All right, let's take a look at question number 11. It says, which function has the greatest y-intercept? So what we're going to do is find the y-intercept of the lines represented by these four options and then determine which one is the biggest. All right, so let's start with the first one, option number 1. We have f of x equals 3x. That can be written as y equals 3x plus 0. So we remember the following. If y equals mx plus b, the constant is the y-intercept. So in this option, option number 1, you're adding on 0. So the y-intercept, b is 0. Which means that the y-intercept for option 1 is 0. All right, let's move on to option 2. We have 2x plus 3y equals 12. We can convert this into slope-intercept form because that form makes the determination of the y-intercept easier. Okay, so for option 2, we have 2x plus 3y equals 12. We need to get y by itself. So we subtract 2x from both sides. That gives us 3y equals negative 2x plus 12. And then we divide everything by 3 in order to get y isolated. And our final result is y equals negative 2/3 x plus 12 over 3, which is 4. So in this case, the y-intercept, which is b, is 4 for option 2. For option 3, we have a slope and a point. So the formula that we're going to be using is y minus y1 equals mx minus x1. Well, actually, we're looking for the y-intercept. Let's try something different. We could use this formula, but to go quicker, we can just find out what b is. So we can use this formula. Let's use y equals mx plus b. And just find what b is. Okay, so y equals mx plus b. We'll just call this our x, call this our y, and this will be our m. All right, so we're going to plug in those values into this equation as we write it here. M is 2 the slope, y is negative 4, and x is 1. So we just want to calculate the y-intercept. Okay, so we have y, let's take that out. Y is negative 4, so we have negative 4 equals m, which is 2, times x, which is 1, plus b. So if we solve this equation for b, that will be our y-intercept. All right, so we have negative 4 equals 2 plus b, and then we subtract 2 from both sides, and that yields the b value of negative 6. Okay, so what does that tell us? It tells us that for option 3, the y-intercept is equal to negative 6 because that is the b value. Okay, all right, number 4, we have a graphical representation of a line. So all we just have to do is read off where the line intersects the y-axis. Okay, that's your y-intercept. So this is your y-axis right here. F of x is equal to y. 1, 2, 3, 4, 5. Bam. That's your b value. That's your y-intercept. Okay, so the y-intercept for option 4 is 5. Okay, so which is the biggest? What was number 1? 1 is 0, so the biggest is option number 4. So answer is option number 4, which is the value of 5. All right, let's take a look at question 12. It says, what is the product of 2x plus 3 and 4x squared minus 5x plus 6? In this case, you're multiplying a binomial with a trinomial. There are different ways you can do it, but let me show you this neat little method. It's called the box method. Okay, so what we'll do is we're going to basically create a multiplication grid, and use it to find the product of these two polynomial functions. All right, so I'm going to have three columns because we have three terms with the second polynomial, and then we're going to have two rows since we have two terms for our first polynomial function. Okay, polynomial expression. So we have those our three columns, and then we have two rows. Okay, so we have 4x squared, negative 5x column, and the 6 column. For the rows, this is a 2x row, and this is the constant of 3 row. Now remember, anytime you're multiplying variables, you have to add the exponents, okay? So 2 times 4 is 8, x times x is x to the third. 2 times negative 5, don't forget the sign is negative 10, x times x is x squared. 2 times 6 is 12, just bring the x along. 3 times 4x squared is 12x to the second power. 3 times negative 5x is negative 15x. And then 3 times 6 is 18. Now, the nice thing about this method is that everything is nicely organized, okay? And there's some visual organizational patterns that we can take advantage of. For example, if you look at this diagonal right here, those are like terms, second degree terms. And also right here, you have first degree terms. So you can just use the visual orientation or configuration of the terms to aid your combination of like terms, all right? 8x to the third stands alone. It has no like terms to be combined with. 12x squared minus 10x squared is a negative, actually positive, since the bigger is positive, positive 2x squared. Negative 15x plus 12x. Subtract, keep the sign of the bigger, negative 3x, and then we're left with positive 18 as the constant. All right, so we can clearly see that our answer is option number 3. Okay, let's take a look at question 13. It says the height of a rocket at selected times is shown in the table. So you have a table right here, time versus height. Based on these data, which statement is not valid? So we're looking for the statement that's not valid, okay? That's not a valid conclusion. Option 1, the rocket was launched from a height of 180 feet. So what this is asking is that at the time 0, h of 0 is equal to 180. Is that the case? If you take a look at the table, at t equals 0, the height was at 180 feet. So that is a valid conclusion. 2, the maximum height of the rocket occurred 3 seconds after launch. So we start at 0, 3 seconds after launch is 3. So what option 2 is saying is that the h max is equal to 324. Now take a look at what happens before and after 3 seconds. 308 and 308. So that automatically helps us to see that 3 falls on the axis of symmetry, which makes the value of y the vertex, the coordinate of the vertex, okay? So remember that the vertex always contains the axis of symmetry and the max or mean of your parabolic function, okay? In this case, it's going up, goes to the max and comes down. So we have the symmetry here between 2 and 4. So the center term, which is 3, gives us a maximum height of 324, okay? And then here we have 4, 308, which is smaller, and then 2, 308, which is smaller. So we can easily see that 3 seconds after launch, we end up at the maximum height of 324, and that option is correct. All right, option 3, the rocket was in the air approximately 3 seconds before hitting the ground. So basically at around 6 seconds, the height should be somewhere close to 0. Is that the case? The answer is absolutely not. 7 seconds later, the ball was still 68 feet from the ground. That's pretty far. Okay, that's pretty far. So Conclusion is that option 3 is false. All right, so this is the answer that we're looking for because h of 6 is not near 0. Okay, is nowhere near 0. Okay, let's take a look at question 14. It says a parking garage charges a base rate of $3.50 for up to 2 hours. Okay, so it's $3.50 flat. That's going to be like our y-intercept, okay? And then an hourly rate for each additional hour. So for each hour after 2 hours, there's going to be an hourly rate. The sign below gives the prices for up to 5 hours of parking. Question: which linear equation can be used to find x, the additional hourly parking rate? So if you look at the options we have here, we have 20, 20, 1450, and 1450. So we're focusing on 4 hours and 5 hours. All right. Now, in order to determine the correct equation, we want to ask ourselves, what's the base and how many hours far is the target hour from 2 hours? Okay, so let's take a look at the 5 hour ones first. So from 5 hours, from 2 we have 1, 2, 3. So it's 3 hours after 2 hours. So for that one, we are going to have the equation, the correct equation should be the base rate, which is $3.50, plus 3, the number of hours, times the rate x, which should give us $20. So this is the equation for 5 hours. Does that match any of these options that we have here? The answer is no. The base rates are wrong, and this one has a correct growth rate of 3x, but the base rate is wrong here. So these two are completely wrong. This is for 5 hours. Now, how about for 4 hours? How many hours is 4 hours away from 2? It's 2 hours, okay? So in that case, we have our base, which is $3.50, plus 2 times the cost. So 2 is the number of hours times the cost, and that should give us the parking fee for 4 hours, which is $14.50, okay? So let me just write down the formula that we're using here so that it's clear. So the formula is basically the base rate, which is $3.50 up to 2 hours, plus the number of hours after 2 hours. So like for example, it's 2 hours after 2 hours, okay? That multiplied by the hourly rate. So in this case, the hourly rate is x. That's what was indicated for us. We're looking for the equation to solve to find x, the hourly rate, okay? And that should give us your charge. So should give us a charge. All right, so that's what we did over here. Base rate of $3.50. Number of hours after 2 hours to get to 4 hours is 2 times the hourly rate, which is x, gives us the charge for 4 hours, which is $14.50. Okay, so we can clearly see that's the correct answer for question number 14 is option number 3. Okay, let's take a look at question 15. It says, which function has a constant rate of change equal to -3? All right, we talked about this in the previous video. The rate of change is the same thing as what? The rate of change is equal to your slope. Okay, and slope is m, which is also y2 minus y1 divided by x2 over x minus x1, which also can be viewed as the rise over run. So the question is asking, in these 4 representations of a linear function, which of them has a slope that is equal to -3? All right. So let's be efficient here. Which one is the easiest to find the slope? Well, I like this one right here. So for option 4, you have 2y equals negative 6x plus 10. Why is it so easy to find the slope here? It's easy because if I can get y by itself, the coefficient of x will be our slope. Okay, so to do that, in just one step, we divide everything by 2. And that yields y equals negative 3x plus 5. Okay, the point slope form of the equation of a line is y, let me use a different color, is y equals mx plus b. The slope or the rate of change is negative 3. Okay, so here the rate of change is equal to negative 3. So that's exactly what we're looking for. The correct answer is option number 4. Okay, now let me go over the other ones, okay, because it's important to know how to compute the rate of change with any of these representations. For option 1, to compute the rate of change, we're going to use the slope formula, the coordinate form, okay? So we're going to do y2 minus y1 over x2 minus x1, okay? So this will be our y2 and our y1, and this will be our x1 and x2. Just pick any ordered pair and call them two ordered pairs, and then you label them accordingly. All right, so y2 is 5 minus y1, 2, divided by x2, which is 1, minus x1, which is 0. If you compute the difference here, you have 3 divided by 1, which is equal to 3. So that's your rate of change for option 1, and we can clearly see that it's incorrect because our target value is negative 3. How about a set of ordered pairs as reflected in option 2? We're going to use the same formula as option 1. Okay, so let's be lazy here. Okay, it doesn't really matter. I'm gonna call the first point x1, y1. What can I call x2, y2? You can pick any ordered pair, okay? If you don't want to deal with negative numbers, you can pick this one right here, but let me pick this one right here, 2 and 2. So we have x2, y2. And then let's go ahead and compute what the slope, the rate of change is. So you have y2 minus y1 over x2 minus x1. All right, so let's see what we get. We get 2 minus 5 divided by 2 minus 1. That gives us negative 3 over 1, which is negative 3. So does that automatically make this the answer also? Well, the answer is no, because we have more ordered pairs here. So in order to break the tie, so to speak, we have to pick another pair. All right, so we're now going to do y3 minus y2 divided by x3 minus x2. All right. Now, if you closely study option 2, it doesn't even look like it's going to be a straight line because you have 5, 2 is decreasing to negative 5 and then increases to 4. That's not even a straight line. Anyway, let's go ahead and compute the slope. So we're going to call this one is x3 and this was y3. If we still get negative 3, we have to use the fourth point. All right, so y3 is negative 5 minus y1, which is 2, divided by x3, which is 3, minus x2, which is 2. Okay, when you carry out the calculations, you have negative 7 over 1, which is negative 7. All right, so we can clearly see option 2 is wrong. Now, option 2 is a big trap because had it been you just pick the first two coordinates and you had tested it, you would end up with -3, but that's not a constant slope. That's just a slope for the first pair of points. After that, it goes to -7, and then it heads to, looks like a positive slope after that. All right, so this is wrong. Now let's look at option 3. What do we have there? Oh, we have a graph. So for option 3, whenever you have a graph that goes nicely into your lattice points, you can use the rise over run formulation of the rate of change, okay? So our rate of change is going to be rise over run. Just use your slope triangle to determine the rise and the run, and then you can go from there, okay? So let's do it. We have a rise of -1, 2, 3, 4. A rise of -4, and so we have a rise of -4 and a run of +2. Okay, so you always want to pay attention to the sign when determining your rise. -4/2. Let me do that again. 1, 2, 3, 4, 4, 2. So a rise of a run is -4/2, which is -2, and that is clearly incorrect. Okay, the only scenario where we have a constant slope of -3 or rate of change of -3 is option number 4. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your preparation for the Algebra 1 Common Core Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. Questions and comments should be placed in the comment section below, and we'll be more than glad to respond. Don't forget to subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching, and have a wonderful day.